Important technique what we are going to see today is internal rate of return. So what is internal rate of return? Internal rate of return is also called as trial and error method. Why do we call this as trial and error method? Is because we have to find the R which typically makes the NPV 0. So the internal rate of return of a project of a discount rate which makes the NPV 0 is what we call it as internal rate of return. So this is one of the widely used technique in the industry. Why? Basically because this gives managers an idea that what is the minimum expected return which possibly they need to have in order to ensure their cash flows meet the basic conditions. Okay, so that's about internal rate of return. So now let's see what are the steps to calculate. So let's possibly take an example and then possibly understand what exactly what are the steps do we follow in terms of solving the internal rate of return. Okay, so let's look at the problem. Okay, so now let's say, for example, there is a project which has the lifespan of 3 years, right? Lifespan of 3 years, let's say 4 years, and the cash flows. So 0 is mainly the cash outflow or the cost of investment. Let's assume that it's 100,000, and then let's say for all the 4 years, you have the 3 years, you have 30,000 for 2 years, then 40,000, and then 45,000. Okay, so this is normally given in the problem. So now what is the first step is so step 1 is we're going to randomly pick an R and see how close it is to 0. Okay, so NPV, anyway, you know the formula. So the first step is to pick the R randomly and calculate the NPV. So NPV is present value of cash inflow minus outflow, right? So let's take some random example and see how it's going to work. So for example, I'm going to take 14% and see what is the value. So present value of cash inflow equals to C divided by 1 plus R to the power of N, right? So C is 30,000 and we have taken 14% to the power of N. So you're going to get 26,315. Okay, and then here 23,084. I'm not taking the point, I'm just rounding off. Okay, so 26,998 and then 26,643. Okay, so now what you have to do is you need to take the total of this. So the total will come to 1,03,042. Okay, so now just apply the formula and see. So NPV is coming to 1 lakh is the present value of cash inflow, 1,03,000 is the present value of cash inflow, and outflow is 1 lakh. So we are getting 3,042. So what we are trying to understand is we need to find the R. So one R which is possibly a negative, which gives you the NPV value of negative, another value gives you the NPV value of positive. But the important thing is it should be as closer as possible. And please remember one thing, this is very important aspects. aspect. So when you keep on increasing your R, right? So if R increases, then your NPV will reduce. So this is an inverse relation. So this is one of the important aspect. In order to save the time, it's important that you remember this. Okay. So now let's take a possibly another R. Possibly let's increase the R and then see how much we are going to get. Okay. So now it's clear that this is not closer to R. So let's take, for example, 15% and then see what is the value we get. So 15%. So follow the same step. So C divided by 1 plus R to the power of 1. If I do it for 15%, then for first year, I'm going to get 26,086 and 22,684, and then I get 26,300, and then I get 25,728. So this again I'm taking randomly. So please remember the checklist what I said. So the main objective of internal rate of return is to find the R, which makes the NPV 0, right? So again, I told you this is a trial and error method. So we need to do multiple times in order to understand which is the R which gives you the NPV value 0. So please understand this is very important. If you keep on increasing your R, then your NPV will reduce. So the best example is you can see here. So we took here 14%, right? So we took 14%, and now we are taking 15%, right? So this is best example what you can see. So if you see when it was 14%, the cash flow was 26,315, and when we increase the R, now you can see it is reduced. It's the same with here. It was 23,084 and now it is 22,684. So the point what I'm saying to say is again the same thing. So when you increase the R, your cash value will reduce, cash flow will reduce. Okay. So the total for 15% is coming to 1,800 minus 81. You see the difference? So I told you, right? So here it was 1,03,000. Now it is reduced to 1,00,000. So now calculate the NPV. So NPV is 800. So how did we get 800? 1,800.81 minus cash outflow is 1,00,000. So you're going to get approximately 801 if I round off this. Okay. So now, so possibly we assume that IRR now it's coming between 15 and 16, because when we took 14%, we got the NPV of 3,000, and now when we took 15%, you see it's a drastic change. So we are assuming that this positive value is closer to 0, and that is 801. So the next 16% it's going to be negative, because if this is the closer value to 0, then of course the next should be the negative value. So let's cross verify that. So let's see what are the values for 16%. So 16%, you're going to get 25,862 and 22,294, and then 25,626, and then 24,853. So then just take the total of that. So total is coming to 98,636. All right. So then calculate the NPV. So NPV is present value of cash inflow minus outflow. So which gives you minus 1363. Okay, so I told you, right? So now we got both the values. So I told you one should be positive, one should be negative, one should give you the negative NPV. So the positive NPV we got 801 and negative we got minus 1363. So now it's very clear that the NPV, the IRR rate is between 15 and 16. Okay, so the 15 is a positive NPV value and the 16 is the negative NPV value. So the first step of internal rate of return is you take the R randomly and see how close the NPV value, to 0. It should be as closer as possible. Okay, so we did that and then we found out that 15 and 16 is the closer value. And then the step 2, what you need to do is you need to find the absolute value. So the absolute value means simply add NPV1 and plus NPV2. Please ignore any negative symbol. So in that case, so NPV1, let's say it's 15% and NPV2 is 16%. So NPV1 we got 801 and NPV2 we got 1363. So ignore any negative symbol. So if you do that, how much we are going to get? So let's calculate that. 1000, let's calculate 1364 plus 801. So you're going to get 2165. So we completed second step. So the third step is to find out what is the NPV ratio. Okay, so the NPV ratio is very simple. So NPV of smaller r divided by NPV of smaller r divided by absolute NPV. So what is the smaller r? In our case, the smaller r is 15%. What is the NPV we got? 801, right? So 801 divided by absolute NPV, what we got is 2165. So 2165. So now what you have to do is just divide 801 divided by 2165. So you are going to get 0.36. Okay, you can take last two digits after decimal point. So now the fourth step is just add smaller r. So our smaller r is 15% and plus whatever you got in step 3, which is 0.36. So IRR is 15.36. So this you can also cross verify. So you can take 15.36 as R and then check what is the NPV value. It should be as closer to 0 as much as possible. So it may be, most of the cases will not get exactly 0. So possibly it will be something like 8, 9, 4 or something like -1, something like that. But it's as closer as possible. So to conclude, IRR, we have 4 steps, and IRR is the internal rate of return, or also called as trial and error method, where you need to find the R which makes the NPV 0. Okay, I hope this video is helpful. See you in another video. Bye bye.